Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I will explain about the rank of a matrix from linear algebra in engineering mathematics. Let me go to the lecture. First, I will define the rank of a matrix. How will you define the rank of a matrix? It is nothing but the highest order non-zero minor of the matrix. Highest order non-zero minor of the matrix. So, I will define the condition to find the rank of a matrix. If the determinant of A equal to 0, if the given matrix is A means we need to find the determinant of A. Determinant of A. If it is equal to 0 for nth order minor, then rank of A, we can conclude that rank of A will be less than n only. Okay, example, if it is a 3 cross 3 matrix, means we need to find the third order minor, that is nothing but the determinant value. If the determinant equal to 0 means we can conclude the rank of A will be less than 3. Either it may be 2 or it may be 1. We can conclude that like that. The other condition is if the determinant is not equal to 0 for nth order minor, then we can conclude that rank of A will be equal to n. Example, for 3 cross 3 matrix, we can conclude the rank of A equal to 3 for the determinant not equal to 0. Okay. So first I will explain about the minus for square matrix. I have considered 3 cross 3 matrix as a square matrix. So here it consists of elements from A11 to A33 are the elements. This is row 1, row 2, row 3. Column 1, column 2, column 3. Okay. It is a 3 cross 3 matrix. Number of third order minor, it is nothing but the determinant value. So it consists of 9 elements, that is equal to 1. Number of third order minor is 1. We know that. And if we want to find the number of second order minors, means we can strike out one column and one row. One column and one row. If we strike out row 3 means I have considered only row 1 and row 2. Okay, row 1 and row 2. If we strike out column 3 and row 3 means the elements are A11, A12, A21 and A22. These 4. And then next this 4. By considering column 2 and column 3. And by considering column 1 and column 3, the minus are A11, A13, A11, A13, A21, A23. So these are the elements by considering row 1 and row 2 by striking out row 3. Okay, and also by striking out any one column. These are the 3 minus by striking out row 3. If we strike out row 1, means the elements are, by striking out column 3, the elements are this one, that is second order minor, and next second order minor is this one, and next second order minor is this one. And if we strike out row 2 and any of the other column, any of the columns, the minors are, if you strike out this row 2, A11, A12, A31, A32, that is the first second order minor. And then if we strike out column 1, the second order minor is this one. And if we strike out column 2, the second order minor is this one. So totally 3 plus 3 plus 3, 9 minus 9 second order minors are there for the 3 cross 3 matrix. And automatically first order minor is nothing but the number of elements in the matrix. We know 3 cross 3 matrix is 3 into 3, number of elements is 9 elements. So first order minus, number of first order minus is 9. Okay. Here I will explain for rectangular matrix also. In the rectangular matrix also we can find the rank of a matrix. So for rectangular matrix I have considered 3 cross 4 matrix. 3 cross 4 matrix consists of 3 rows and 4 columns. So to find out the third order minus, we can strike out one column. We can strike out one column, either column 4 or column 3 or column 1 or column 2 or column 1. Okay, by striking out one column, we can find the third order minus. Okay, here also the highest order is third order only, because we need to consider the number of rows only. Here number of rows is 3, number of columns only 4. So the highest order is third order. So number of third order minus is, by striking out one column here, R1, R2, R3 or row 1, row 2, row 3. By striking out last column, the elements, the minor is, third order minor is this one. Full combination. First column, second column, third column. And then by striking out third column, The other elements are, the second order minor is consists of first column, second column and fourth column. And also by striking out second column, the third order minor is this one. And by striking out first column, the other elements, that is nothing but third order minor. So total number of third order minors is 4 minors. Okay, 4 third order minors. And if we want to find out the second order minors, we can strike out 2 columns and 1 row. 2 columns and 1 row. We can strike out 2 columns and 1 row. If we strike out 2 columns and 1 row, means we can find the second order minor. Okay. We can find the second order minor. So like that we can find the second order minor by considering by striking out 2 columns and 1 row. Here I have considered row 1 and row 2, and column 3 and column 4 had been stricken out, and here the other elements are like this. So by striking out first column and fourth column, the second order minor is this one. And first column and second column, by striking out first column and second column, this one. And by striking out second column and fourth column, this one. Okay, this is column 1 2 combination, then 2 3 combination, then 3 4 combination, and then 1 3 combination, and then 1 4 combination, and then 2 4 combination. Okay, so for each strikeout of row, for each one row strikeout, there are 6 second order minors. So there are totally 3 rows. So we have to strike out 3 rows. So number of rows are 3. By striking out 1 row, 6 minors are coming. 6 second order minors are coming. And by striking out 3 rows, number of second order minors will be equal to 6 into 3, that is equal to totally 18 second order minors will be coming. Okay, for the 3 cross 4 matrix, number of second order minors will be equal to 18 minors are there. And first order minus, that is equal to 12, because it is a 3 cross 4 matrix. 3 cross 4 equal to 12. 12 number of elements are there. First order minus equal to 12. So this is about the rectangular matrix minus and square matrix minus. And now I will explain about the methods to find the rank of a matrix. There are 2 methods. One is determinant method, and we need to check with the minus. And the other one is elementary transformation method. We need to check the elements with the diagonal elements of the matrix. So I will explain both the method. First I will explain the determinant method. Determinant method is nothing but, first step is to find the nth order determinant, that is nth order minor. We need to find the nth order minor. I termed as delta n. We need to check whether it is 0 or non-zero. Determinant of nth order determinant. If it is not equal to 0, means we can conclude the rank of the matrix equal to n. If it is equal to 0, nth order minor equal to 0, then we can check with the lowest order minus, that is n minus 1th order minus. For 3 cross 3 matrix, we can check for the second order minus. Okay, for 4 cross 4 matrix, we need to check for the third order minus, second order minus, and also first order minus. So we need to check with the lowest order minus, n minus 1th order minus, whether it is 0 or non-zero. Again, if it is 0 means we can conclude. If it is non-zero means we can conclude that rank equal to n minus 1. If it is equal to 0 means we can check with the n minus 2th order. That is up to first order we can continue. If 0 means continue backwards up to first order minor delta 1. And then about the elementary transformation method, I will tell you the steps. First, we need to reduce the matrix to diagonal form. What is the diagonal form? Diagonal form, if it is a 3 cross 3 matrix, means first row first element, second row second element, third row third element should be there. That is a diagonal element, diagonal form. Other than the diagonal values, there should be 0. Okay, we can reduce the matrix like that. Reduce the given matrix to the diagonal form. Then we can conclude. Then we can count the number of elements in the principal diagonal. The number of diagonal elements that will be equal to rank. If the number of diagonal elements are 2 means we can conclude the rank of the matrix is 2. If the number of diagonal elements are 3 means we can conclude the rank of the matrix is 3. Okay, if only one diagonal element is there means we can conclude that rank is 1. So this is about the elementary transformation method to find out the rank of a matrix, and for the and also the determinant method to find out the rank of a matrix. For every square matrix, it has rank less than or equal to n. Okay. I will give you example problem for the square matrix. And I have considered square matrix. It is nothing but a 3 cross 3 matrix. First, I will explain the determinant method. Okay. Here I am going to explain both methods. First, I will explain the determinant method, that is check with the minus. So we know 3 cross 3 matrix consists of 3 minus, third order minor, second order minor, first order minor. First we can check with the third order minor. Third order minor is nothing but a determinant value. Let me find the determinant value. Let me find the determinant value. Here I have termed as delta 3, third order minor. Okay. So for determining the determinant, first element is 1. For the second element only negative. 1 into 21 minus 23 into 7 21 minus 20 minus 2. But for the second element, sign should be considered as negative. So minus 2 into 14. 7 2s are 14 minus 3 4s are 12. Minus 12 plus 5 is the third element into 10. 2 5s are 10 minus 9. That is equal to 1 minus 4 plus 5 equal to 2. So here third order minor is not 0. It is a non-zero condition. So non-zero condition means we can conclude the rank of the matrix as 3 itself. No, there is no need to check with the lowest order minus. So here itself we can conclude that rank of the given matrix as 3, because the highest order third order minus is not equal to 0. Value is coming. So we can conclude the rank of the matrix as 3. So this is about the determinant method for this matrix. And then I will explain about the elementary transformation method. We need to reduce the given matrix to diagonal form. Okay. So for the reduction, we need to consider the principal diagonal elements. So this is the principal diagonal elements. 1, 3, 7 are the principal diagonal elements. This is the lowest triangular form. So this is the lowest lower triangular elements. First we need to reduce this lower triangular elements as 0. How can you reduce this as 0? So we can consider this second row. Okay, second row consists of 2. Second row first element is 2, and first row first element is 1. Here I am going to reduce as row 2 tends to row 2 minus 2r1, r2 minus 2r1. Okay, r2 tends to r2 minus 2r1. r2 minus 2r1 means 2 minus 1 into 2, it becomes 0. It will become 0. We are making that element as 0. Okay, so r2 minus 2r1. So we are considering row 2 as row 2 minus 2r1. And 3, when we consider this third row first element and first row first element, we can consider 3 1. So if it becomes 3 minus 3 means it will become 0. So 3 minus 3 into 1. So row 3 minus 3 into row 1. So we can make R3 as R3 minus 3R1. So using this, we can reduce like this. So row 2 minus 2r1. So this element will become 0, and 3 minus 2 into 2, that will become minus 1, and 4 minus 2 into 5, that is 4 minus 10 is minus 6, and here for row 3, 3 minus 1 into 3, that becomes 0, and 5 minus 6 minus 1, and 7 minus 15, that is minus 8. Okay, here these two elements had been reduced. Again, we need to reduce this element. So for the reduction of this element, row 3 should be considered as row 3 minus row 2. So minus 1, here also minus 1. So minus 1 minus of minus 1, that will become plus 1. So we can reduce like that. So minus 1 minus of minus 1, minus 1 plus 1 will become 0. Okay. So we can change the row like this. So if we put this condition, this row will become 0, 0, minus 2. So lower triangular elements become 0. Now we need to consider for the upper triangular elements, that is 2, 5, minus 6 should be reduced. For that, columns can be considered. Okay, upper triangular elements are 2, 5, 4. This 2, 5, 4 should be reduced to 0. So we need to consider this matrix 2, 5, minus 6. 2, 5, minus 6. Okay, 2, 5, minus 6. This 2, 5, minus 6 should be reduced to 0. For that, we can consider column 2. So, column 2 can be reduced to column 2 minus 2c1. 2 minus 1 into 2, that can become 0. And 5 minus 5 into 1, that can become 0. So, like that, column 2 minus 2c1, column 3 tends to column 3 minus 5c1. So, we can make the column change. So 2 minus 1 into 2, that becomes 0, and minus 1 minus of 0 into anything, that is minus 1 only. Here also 0, and 5 minus 1 into 5, that is 0 only, and minus 6 minus 2. Okay, so here again this element we have to reduce this as 0. For that, we can consider the C3 plus 6C2. Okay, column 3 plus 6C2. Column 3 plus 6C2. Okay, column 2 and column 3 combination. With that, we can reduce that as also 0. That is also 0. So 1 minus 1 minus 2. Okay, 1 minus 1 minus 2. So there are 3 elements. Again we can reduce. There are 3 principal diagonal elements. Other than this, we cannot reduce because upper triangular values are 0, lower triangular values are 0. We cannot reduce much. Only the 3 diagonal elements are there. Up to this we can stop it. Okay. Now we can consider row 2 as row 2 by minus 1. Okay, minus 1 can be reduced to 1 form, and minus 2 can be reduced to 1 form. So row 3 by minus 2, that will become 1. So 1, 1, 1. So after reduction, the principal diagonal elements are 1. Only the principal diagonal elements are there. Other than that, all others are 0. We cannot reduce much. So there are 3 principal diagonal elements. So we can conclude the rank of the matrix as 3 itself. Okay. This is for elementary transformation method. And for the rectangular matrix, I have considered 3 cross 3 4 matrix. I have considered 3 cross 4 matrix. Here number of third order minuses, 4 minus are there. So already I have explained about the third order minus. So here any one third order minor we can find. First I have considered column 1, column 2 and column 3 only. So we can find the minor value. So if minor value is nothing but the determinant value of this 3 cross 3 matrix. Here the determinant value I have found out as 0. So I have found out as 0. So again you can check for the other matrix also by considering column 2, column 3 and column 4. So by considering column 2, column 3 and column 4 also, again 0 is coming. So we can conclude delta 3, we can conclude for third order minor, this determinant, the minor value equal to 0. Then we should check for second order minus. For third order minus equal to 0. So rank of A is not equal to 3. Rank of A, we can conclude that rank of A should be less than 3 only. So we can check for the second order minor. We can check for the second order minor. So second order minor, here I have considered the column 1 and column 2, row 1 and row 2. So 1, 1, 4, minus 2. First 4 elements. Okay. We need to find the second order minor. That is equal to minus 6. We know minus 6 is not equal to 0. And delta 2, 2 is the second column, third column, row 1, row 2. So 1 minus 3 minus 2, 6. That is equal to 0 only. And again delta 2, 3 other second order minus, that is equal to minus 18, that is not equal to 0. If any one minor is not 0 means we can conclude that as a rank of a matrix. Okay. So here this first second order minus, that is also not equal to 0. Third second order minor, that is also not equal to 0. There is no need to find the other second order minus. We can conclude the rank of the given matrix as 2 itself. Okay. So if we find for elementary transformation method for this 3 cross 4 matrix, 3 cross 4 matrix, we need to consider these elements: row 2 element, row 2 first element, and row 3 first element. So 4 minus 1 into 4, that will become 0. 15 minus 1 into 50, that will become 0. So we can write the equation as R2 minus 4R1, R3 minus 15R1. So R2 tends to R2 minus 4R1, R3 tends to R3 minus 15R1. So by considering that, the row elements will become like this. Okay, simplifying the row 2 and row 3 elements. So row 2 is simplified as row 2 by minus 6, and row 3 is simplified as row 3 by minus 18. So the simplified form is this one. The matrix, the simplified form of the matrix is this one. Now see this matrix, we can reduce further. Here 1, 1, minus 3, minus 3, minus 2, minus 2. So 1 minus 1. So this row 3 can be reduced. Row 3 or row 2 can be reduced. So by considering row 3 minus row 2, all the third row elements will become 0. Okay, 1 minus 1, 0, minus 3, minus of minus 3, that is 0, minus 2, minus of minus 2, that becomes 0. So we have reduced the form to 2 rows. Here third row become 0. We can see further. How can it be reduced? Here minus 3, and minus 1, minus 2. We can consider column 2 and column 3. So here two elements are same, column 2 and column 3. Here also minus 3, and here also 1, 1. So column 2 minus column 1, and then here column 2 minus column 1, and here column 3 plus 3C2. Column 4 tends to column 4 plus 2C2. So after reduction, the form is like this. So other than the two diagonal elements, other things are 0. Here we cannot consider the principal diagonal elements because it is not a square matrix, it is a rectangular matrix. So to find out the rank of a matrix, we need to consider the number of row elements here. So here the number of row elements is: first row has one element, second row has one element, third row has no values. So we can conclude the rank of the matrix as there are two row elements. Number of row elements should be considered to find out the rank of a matrix. So here we can conclude rank of A is 2. Number of row elements after reduction. So we can conclude the rank of the given rectangular matrix as 2. So this is about the elementary transformation method to find out the rank of a matrix. Thank you for watching the video. This is Mani's Gate Tech Vision. This is the channel for engineering competitive examination. You can subscribe to my channel and you can share the videos and view the videos regularly. This is my mail ID. Thank you very much for watching the video. Thank you.